So far we've talked about compounds that form between a metal and a nonmetal. And when these two things combine, one becomes a positive ion, usually the metal, and the nonmetal becomes the negative ion, and they attract to form an ionic compound. And in this compound we have ionic bonds. In these bonds we have a positive ion, such as sodium, attracted to a chloride ion, and that pattern repeats to form a repeating crystal. But what happens if we don't have a metal and a nonmetal? What about a metal and a metal? Can these form compounds? Well, in general, when we say metals and metals combine, we don't think about them forming a compound. They just form a metal if it's only one element. So if it's just all copper, it would be copper metal, or an alloy. And an alloy is a mixture of different types of metal atoms. And these metal-metal bonds look very different than ionic bonds. Let's look at a picture. In this image, you can actually start to see the metallic bonds. What exactly are we looking at? Well, the background atoms, the background circles, are copper atoms, and on top are larger palladium atoms. This is an actual image of atoms. So you're not seeing a drawing or anything like that. This is taken with something called a scanning tunneling microscope, and you can see the atoms. And you can see they're packed close together. Their atoms have different sizes, and they're all being held together very closely. If we look at a cartoon sketch of what's really going on, because we can't really see the nuclei and the electrons in the image, we can see that metallic bonds have nuclei close together, but they have these electrons scattered between them. And we can think of these electrons actually as a sea of electrons. And just like the actual sea or the ocean, these electrons can flow back and forth between the nuclei. And that's holding the nuclei together. And what this does is it allows metals to carry current. If most of the electrons end up going in this direction, we actually have an electric current. This is why metals are very good conductors. Their electrons are free to move around all of the metal nuclei. The last type of bond we can talk about, or compound we can talk about, is what happens when you have two nonmetals. So a nonmetal plus a nonmetal. And what this becomes is what is known as a molecular compound, also known as a covalent compound. The word covalent actually tells us what these compounds are, what the bonds are like. So co means sharing or together, and valent refers to valence electrons. Covalent. These are atoms that share their valence electrons. And when they do this, the bond that is formed is called a covalent bond. And a covalent bond is the sharing of two valence electrons between atoms. And this is what holds a nonmetal or molecular compound together. So let's look at an example. If I have two carbon atoms, they are both nonmetals. So the way they will be bonded is with a pair of electrons. So these two electrons here are going to be shared between the two carbon atoms. And since both of these electrons are needed by both atoms to complete their octet, they are going to form a stable bond. So carbon, we can represent that covalent bond as a single line. So a covalent bond is between two nonmetals, and it's a pair of shared electrons. We can also have a double covalent bond where we have 4 electrons in there. So each bond has 2 electrons in it. And we can even have a triple bond where we have 6 electrons between it. But no matter what, each of the individual bonds only has 2 shared electrons.